All right, today's presentation is on mole stoichiometry. So by the end of this lesson, you will be able to calculate the number of moles of a product given the number of moles of a reactant in a chemical reaction. So don't be afraid of the word stoichiometry. All it means is the math that you do in relation to a balanced chemical equation. So here we go. We're going to use this reaction to demonstrate this math that you're going to do. So this reaction shows that solid aluminum is reacting with oxygen gas to produce solid aluminum oxide. And you can see that this equation is balanced already with some coefficients. And I want you to think of the coefficients as representing the number of moles of each of these reactants and the product. So you could also read this equation as 4 moles of solid aluminum react with 3 moles of oxygen gas to produce 2 moles of solid aluminum oxide. So let's look at some simple problems to begin with. So in letter A, it says how many moles of oxygen gas react with 4 moles of aluminum. So this problem is very simple because 4 moles of aluminum are given in the balanced chemical equation. They ask us about oxygen gas. So if there are 4 moles of aluminum, there must be 3 moles of oxygen gas reacting with it. So our answer will have a number, units, which in this case is the mole, and a compound, oxygen gas. How many moles of aluminum oxide are produced by the reaction of 3 moles of oxygen gas? So again, they give us 3 moles of oxygen gas in the balanced equation. So we just look over here, they're asking us about aluminum oxide, which is this guy down here. There's a coefficient of 2. So our answer here is 2 moles of aluminum oxide. Last one, how many moles of aluminum react with 3 moles of oxygen gas? This is exactly the opposite of question A. So they're giving us 3 moles of oxygen gas, asking for aluminum, the answer is 4. So we write 4 moles of aluminum. Try 3 very similar problems on your own having to do with the reaction of magnesium burning in oxygen gas to produce magnesium oxide. Hit pause, come back when you have answers for all 3. All right, let's look at some answers here. For letter A, how many moles of oxygen gas, that's this one, react with 2 moles of magnesium? So we already have 2 moles of magnesium, and don't forget that there's an invisible 1 right there. So 1 mole of oxygen gas. How many moles of magnesium react with 1 mole of oxygen gas? This is exactly the opposite problem. We have 1 mole of oxygen gas requires 2 moles of magnesium. And finally, how many moles of magnesium oxide are produced by the reaction of 2 moles of magnesium in excess oxygen gas? The very last part of this problem, the in excess oxygen gas, don't worry about that. All it means is that you won't run out of oxygen gas. So we're just going to ignore that. So 2 moles of magnesium, and we want to go from magnesium to magnesium oxide. So for every 2 moles of magnesium, there are also 2 moles of magnesium oxide. There it is. So we're going to look at the same equation again, but this time, what if they don't give us the exact coefficients that are given in the balanced equation? So for example, in letter A, how many moles of oxygen gas react with 8 moles of aluminum? So this time, we have 8 moles of aluminum. So I want you to see that they give us a number that's exactly twice as much as the coefficient. So we're going to go over to oxygen, which they ask about, and it's exactly twice as much, so it must be 6. There is another way to do these problems where you write down what they give you, so 8 moles of aluminum. This involves a little bit more math. We're going to make a fraction. The coefficient for the thing you start with goes on the bottom. You don't want it anymore. So we're going to put 4 moles of aluminum on the bottom. And the thing that we do want, oxygen gas, that coefficient goes on the top. You know from your math class that if you have something on the top of a fraction and on the bottom, those units cancel. And we do 8 times 3, which is 24, divided by 4, which is 6. And our units are the only thing we didn't cross out. All right, how many moles of aluminum oxide? All right, letter B, how many moles of aluminum oxide, so that's this guy up here, are produced by the reaction of 9 moles of oxygen gas? So you can see that we have to multiply the coefficient by 3 to get 9. So we can come over here and do the same thing and get 6. Or we can use the other method that I showed above. Write down what you know. 9 moles of oxygen gas. Make a fraction. The coefficient of the thing you start with, so here oxygen gas goes on the bottom. And the coefficient of the thing you want to get, which in this case is aluminum oxide, goes on the top. And we end up with 9 times 2, which is 18, divided by 3 is 6. Great. One more. How many moles of aluminum react with 1.5 moles of oxygen gas? So if you look up here in the balanced equation, 1.5 moles of oxygen gas is exactly half of the coefficient. So we divided by 2. So we're going to do the same thing for the thing they ask us about. So they're asking us about aluminum. We're going to divide 4 by 2, and that gives us 2 moles of aluminum. Or you can do the work like we did above. All right, so here are 3 problems for you to try on your own. Work out the answers and hit play again when you come back. All right, here you go. For the first one, they give you 4 moles of magnesium. So that's twice as big as this coefficient. They ask about oxygen gas, which has an invisible coefficient of 1. So if we do twice that, we're going to end up with 2 moles of oxygen gas. Or you can show all your work. Write down what they give you. Make a fraction that's 2 stories tall. The coefficient for the thing you don't want goes in the bottom. So 2 moles of magnesium. The thing you do want, oxygen, goes on the top. 4 times 1 is 4, divided by 2 is 2 moles of oxygen. All right, letter B. How many moles of magnesium react with 3 moles of oxygen gas? So if they give us 3 moles of oxygen gas, that's 3 times as many as we started with as the coefficient. So they're asking us about magnesium, so we're going to do 3 times that of magnesium to get 6. So 6 moles of magnesium, or showing the work, 3 moles of oxygen gas. Make a fraction. Coefficient of oxygen goes on the bottom because we want to get rid of it. And we're looking for magnesium, so that coefficient goes on the top. 3 times 2 is 6, divided by 1 is 6. There we go. All right, letter C. How many moles of magnesium oxide are produced by the reaction of 1 mole of magnesium in excess oxygen? So again, we don't need to worry about this in excess oxygen gas. It just means we're going to run out of magnesium first. So if we have 1 mole of magnesium, that's half as many as the coefficient. And we're looking down here at magnesium oxide, so we need half as many, so divided by 2, and that gives you 1 mole. So our answer down here, 1 mole of magnesium oxide. So one more type of problem, these are the most complex. It's when not only do you not have the same as the coefficients in the balanced equation, you have a number that's not a multiple of one of the coefficients. So let's look at this. How many moles of oxygen gas react with 3.5 moles of aluminum? So I'm going to make a little annotation on the equation so I can keep all of this straight. How many moles of oxygen gas? I'm going to make a question mark because I don't know. React with 3.50 moles of aluminum. So we're going to write down what they give us. We're going to make a fraction. I don't want aluminum anymore, so aluminum's coefficient goes down here. but I do want moles of oxygen gas. So the coefficient for oxygen goes up on top. And I'm going to get out my calculator because this one I can't do in my head. So 3.5 times 3 divided by 4, and I get 2.625. I'm going to round that a little bit. I only have 3 significant figures here, so an appropriate answer would be 2.63. And then I can't forget to write units, moles, and then the compound, oxygen. Let's look at one more. How many moles of aluminum oxide, so that's this guy, I'm going to write a question mark, are produced by the reaction of 5 moles of oxygen gas? So I'm going to write down what I'm given. 5 moles of oxygen gas. Make a big fraction. What I don't want anymore goes on the bottom, so oxygen has a coefficient of 3. What I do want at the end, aluminum oxide, that coefficient goes on the top. And I'm going to do the math. 5 times 2 is 10, divided by 3 gives me 3.3 repeating forever. So I'm going to round that. I actually need 3 significant figures. So we can just do this. We can truncate it after the third 3 and give it some units. Moles of Al2O3. Here are 2 similar problems for you to try. Hit pause, come back when you have your answers. All right, in the first problem, they start us with 9.5 moles of magnesium. We don't want magnesium anymore. In fact, we want moles of oxygen gas instead. So the coefficient for magnesium goes on the bottom. And the coefficient for oxygen gas, which is invisible 1, goes on the top. And we're going to do 9.5 divided by 2 is 4.75. Let's see, only 2 significant figures here, so I can safely round that to 4.8 moles of oxygen gas. In the next one, they start us with 5 moles of magnesium, 5.00 moles, and ask about how many moles of magnesium oxide will be produced. So my coefficient for magnesium, 2, goes in the bottom. My coefficient for magnesium oxide, which is also 2. Oh, easy math here. 5 times 2 divided by 2 is just 5.00 moles of magnesium oxide. And since they gave us 2 decimal places after the decimal point in the problem, I can safely use that in my answer. So at this point, you can now calculate the number of moles of a product given the number of moles of reactant in a balanced chemical equation.